A typical selector switch operator is made of a conducting wafer that is rotated by a knob. A different circuit is connected to each individual terminal. As the wafer rotates, the switch closes on each circuit in turn, allowing current to flow through that circuit. Selector switches can be made with more than two positions. Each position will make a different connection. This is the schematic symbol for a simple selector switch. The selector switch on the operator station panel of the 85MT5 has two normally open contact blocks. One is for the left-hand position and one is for the right-hand position. Here is the schematic diagram of the three-position selector switch on the 85MT5 operator station. The center position does not operate any contacts. If the selector switch is set to the center position, both sets of contacts are in their normal state, open. Selector switches have a number of different operator types available, including knob, lever, and key lock. These operators are available with 2, 3, or 4 positions. Selector switches are often used to change the mode of operation of a machine. Typical applications include on-off, manual automatic, run jog, and forward reverse. Each position of the selector switch will cause the machine to change to a different mode of operation. In most cases, the selector switch will be mounted with a legend that identifies the function of each position. Selector switches can be momentary or maintained, like push-button switches. One example of a momentary selector switch is an ignition switch on an automobile. An example of a maintained selector switch is the hot, warm, cold temperature selector on a washing machine. Connect and operate a basic electric control circuit using a selector switch. In this procedure, you will connect a simple circuit that includes a selector switch. You will then operate the circuit using the selector switch to change conditions in the circuit. Select Simulator or Hardware to perform this procedure. Once you have completed one, you may go through the other. A ladder diagram is a type of electrical schematic that represents circuits in a clear, concise manner. Circuits represented this way are much easier to read than pictorial schematics. The electrical wires on a ladder diagram are arranged in orderly rows like the rungs on a ladder. All components, switches, lights, etc., are placed on the rungs, which are also referred to as lines. The words lines and rungs are used interchangeably when discussing ladder diagrams. Describe the function of four components. The four components of a ladder diagram correspond to the four basic components of an electrical circuit: the power supply, the input devices, the output devices, and the conductors. The power supply provides the source of power that energizes the output devices. No matter which type of power supply is used in a ladder diagram, it will be represented by two vertical lines. L1 is the hot or positive side of the power supply. N is the ground or negative side. On an AC supply, the supply rails can either come from a control transformer or directly from the main power lines. If the supply is from a control transformer, the rails are often not labeled or labeled as X1 and X2. The Amatrol 85 MT5 trainer uses a special control transformer with a tap, and the rails are labeled X1 and X2. The input devices are used to perform the logic functions that control the output devices. They are always connected between L1 and the output devices. The various input devices are each represented by a different symbol. The normally open push button looks like this. As you can see, if the push button were pressed, the current could flow between the contacts. The normally closed push button looks like this. If the push button were pressed, the current could no longer flow between the contacts. The selector switch is shown this way. When the selector switch is in the center position, no current flows between any of the contacts. When the switch is pushed to the left, current flows between the upper set of contacts. When the switch is pushed to the right, current flows between the lower set. Output devices cause the machine to perform its operation. They are always located between the input devices and neutral. The indicator lamps are represented by this symbol. The letter in the center of the circle indicates the color of the lamp. In this example, the G means that the lamp is colored green. Conductors are the electrical wires that connect the circuit. They are represented as horizontal lines on a ladder diagram. They form the rungs or lines of the ladder, allowing electricity to flow between L1 and N. L1 is the hot or positive side of the power supply. N is the ground or negative side. It is important to be aware that the component symbols used in ladder diagrams may be different than those used in electrical schematic diagrams. Describe 6 rules of drawing a ladder diagram. There are 6 rules that should be followed whenever drawing a ladder logic diagram. These rules help keep ladder logic diagrams simple and easy to understand. Rule number 1. all components must be labeled. Rule number 2. All conductors must be numbered. Rule number 3. All lines must be numbered. Rule number 4. Only show control devices. Rule number 5. Place only one load per line. Rule number 6. There are 6 rules that should be followed whenever drawing a ladder logic diagram. These rules help keep ladder logic diagrams simple and easy to understand. Rule number 1. All components must be labeled. Rule number 2. All conductors must be numbered. Rule number 3. All lines must be numbered. Rule number 4. Only show control devices. Rule number 5. Place only one load per line. Rule number 6. Output devices are located on the right. Each component in a ladder diagram should be labeled with its function, such as start, as well as some way to identify it, such as 1PB. The wires connecting the components should be numbered left to right and top to bottom. As you know, the vertical lines representing the power supply are labeled L1 for line 1 and N for neutral. Any wires connected to L1 will be numbered 1. The wires connected to N will be numbered 2. In addition, conductors that are joined together directly will all share the same conductor number. Notice conductor number 3. A line is considered any horizontal level where conductors in the circuit run. Control devices include switches, solenoids, and relays. Ladder diagrams should not show power devices such as valves, motors, and cylinders. Power devices are shown on a separate diagram called a power diagram. Load is simply another name for an output device. Loads should always be wired in parallel on different lines, never in series on the same line. Output devices such as solenoids, lamps, relay coils, and contactor coils should always be located on the right side of the ladder line with one terminal connected directly to the right power rail. Ladder diagrams help you to read the operation of a circuit more easily because it unravels the lines and allows the diagram to be read in an orderly fashion. By looking at the input devices on the left, it is easy to determine which output devices on the right side are on or off. When ladder diagrams are used to perform a sequence of steps, the lines are usually arranged so that the output devices are placed from top to bottom in the order in which they are energized. Draw a ladder diagram of a control circuit. In this skill, you will study a drawing of a circuit connected on the 85 MT5 trainer, and then you will draw the ladder diagram for the circuit. This will demonstrate the orderly layout of components in a ladder diagram. Click on the pencil and paper to view this. Describe how to determine the operation of a circuit. The best method for reading a ladder diagram is to start at the upper left of the diagram at the first input on the first line. Then work your way across the line before moving down to the first input on the next line. This is true whether you want to determine the sequence of operation of the circuit represented or construct an actual circuit from the diagram. When determining the sequence of operation of a circuit from a ladder diagram, first determine the state of all outputs when all inputs are in their deactivated or normal states. Keep in mind that in order for an output to be energized, there must be a complete circuit from the left power rail, through any inputs, through the output, and on to the right power rail. Start with line 1 and trace the circuit from left to right to determine if any outputs on that line are energized. Then, move along any branches to determine if there is a complete circuit along line 1 to any outputs on lower lines. Continue to the next line, checking outputs on this line first, then moving up or down any branches. Once you have determined the initial state of all the outputs on the diagram, the next step is to determine the states of all outputs as each of the inputs is energized. For example, determine which indicator lamps come on or go off as each of the buttons are pressed. Determine the operation of a control circuit given a ladder diagram. In this procedure, you will use a ladder diagram to determine the operation of a control circuit. You will be shown several ladder diagrams and asked to determine the status of the outputs. Click on the pencil and paper to view the step-by-step instructions for performing this procedure. In this procedure, you will determine the operation of a circuit given the ladder diagram. You will then connect the circuit using only the ladder diagram as a reference. Select Simulator or Hardware to perform this procedure. Once you have completed one, you may go through the other. There are 6 ways input switches and relay switches can be connected in a circuit. These are called logic elements. Logic elements form the basic building blocks to create very complex sequences. A control logic circuit uses these elements to perform operations in automation and motor control. The 6 logic elements of control logic are and, or, not, nor, NAND, and memory. Describe the operation of AND logic and give an application. An AND logic circuit is made of 2 normally open switches. An AND logic circuit is made of 2 normally open switches wired in series. Both switches must be closed to energize the output. An application of an AND logic circuit is a 2-hand circuit. A 2-hand circuit requires both hands to be used to start a machine to protect the operator's hands. This is done by having each hand press a separate push button at the same time. The machine will only start if button 1 and button 2 are pressed. As soon as either button is released, the machine will either stop or move to a safe position. This action to practice use. As soon as either button is released, the machine will either stop or move to a safe position. This action ensures that both hands are safely removed from the machine's work area during operation. To practice using AND logic, operate the following circuit, which is similar to the two-hand circuit. The two-hand circuit shown in this objective is not a complete OSHA-approved circuit. Actual two-hand circuits in use today will have additional components to ensure the safety of the operator. In this procedure, you will connect and operate an AND logic control circuit that controls an indicator lamp. Select Simulator or Hardware to perform this procedure. Once you have completed one, you may go through the other. Describe the operation of OR logic and give an application. An OR logic circuit is made of two normally open switches wired in parallel. Closing either of the switches will energize the output. Closing both switches will also energize the output. To practice using OR logic, operate the following circuit. The light should come on when either the top button is pressed or the bottom button is pressed. An application of an OR logic circuit is a remote start button. A remote start button allows an operator to start a machine without having to be standing near it. The SIM line will start when the normal start button is pressed or the remote start button is pressed. Connect and operate an OR logic circuit. Select Simulator or Hardware to perform this procedure. Once you have completed one, you may go through the other. Describe the operation of NOT logic. A NOT logic circuit is made of one normally closed switch wired in series with the output. Pressing the switch will open the circuit, which will de-energize the output. A common application of NOT logic is an emergency stop push button, like those on CNC machines. In an emergency, the E-stop can be pressed, which will cut all power to the CNC machine. In other words, the output, the CNC machine, is active when the E-stop is not pressed. In this procedure, you will connect an electrical control circuit using NOT logic with a normally closed switch to provide a stop button. Select Simulator or Hardware to perform this procedure. Once you have completed one, you may go through the other. Describe the operation of NOR logic and give an application. A NOR logic circuit is made of two normally closed switches wired in series. Opening either of the switches will de-energize the output. Opening both switches will also de-energize the output. An application of a NOR logic circuit is a remote stop button. Pressing the normal stop button will stop the SIM line. Pressing the remote stop button will stop the line as well. The SIM line will run when neither the first button nor the second button is pressed. These two stop buttons are wired in series. In this, select Simulator or Hardware to perform this procedure. Once you have completed one, you may go through the other. A NAND logic circuit is made of two or more normally closed switches wired in parallel. Opening either of the switches will have no effect on the circuit. The output remains energized. It is necessary to open all of the switches to de-energize the output. An application of a NAND logic circuit
is the interior light circuit in a car. The light will always be on unless all the doors are closed. As soon as any of the doors are opened, the light will come on again.
In this procedure, you will connect a control circuit that requires pressing 2 push buttons to stop an output device. The output device is an indicator lamp. Select Simulator or Hardware to perform this procedure. Once you have completed one, you may go through the other. In this procedure, you will design a control circuit that uses multiple switches and indicator lamps to simulate the operation of a machine in both automatic and manual modes. Select Simulator or Hardware to perform